Cache. What is cache? No, you know exactly what is cache. Today we are going to talk about computing cache. In computing, a cache is a hardware or software component that stores recently used information so that it can be quickly accessed at a later time. In other words, caching allows you to efficiently reuse previously retrieved or computed data. Cache shortens data access time, reduces latency, and improves input, output, and improves application performance. Common types of caches include browser cache, disk cache, memory cache, and processor cache. The data in a cache is generally stored in a fast access hardware, such as RAM, that stands for Random Access Memory. Remember that cache is frequently used by cache clients, such as the CPU, applications, web browsers, or operating systems. Now let's get into two types of caches. First, cache hit. A cache hit occurs when the requested data can be found in a cache. If the requested data isn't found in the cache, a situation known as a cache miss, it is pulled from the main memory and copied into the cache. Cache hits are served by reading data from the cache, which is faster than recomputing a result or reading from a slower data store. Thus, the more requests that can be served from the cache, the faster the system performs. Remember that the percentage of accesses that result in cache hits is known as the hit rate or hit ratio of the cache. Cache instructions for how the cache should be maintained are provided by cache algorithms. Some examples of cache algorithms include LFU, which stands for least frequently used, is a type of cache algorithm used to manage memory within a computer. When the cache is full and it requires more room, the system will purge the item with the lowest reference frequency. LFU is sometimes combined with the least recently used algorithm and called LRFU. LRU, which stands for least recently used, it's a cache replacement algorithm that removes the least recently used data to free up space for the new data. MRU, which stands for most recently used. This cache algorithm removes the most recently used items first. An MRU algorithm is good in situations in which the older an item is, the more likely it is to be accessed. As we said before, we have common types of caches, include browser cache, disk cache, memory cache, and processor cache. So let's get into them. First, we have the web cache, which is a software cache. Most web browsers such as Internet Explorer, Firefox, Safari, and Chrome use a browser cache to improve performance of frequently accessed web pages and cache the web page data by default. For example, when you visit a web page, the browser might cache the HTML, images, and any CSS or JavaScript files referenced by the page. When you browse through other pages on the site that use the same images, CSS, or JavaScript, your browser will not have to re-download the files. Or even clicking back and returning to a previous page enables your browser to retrieve most of the files it needs from the cache. Instead of having them all resent from the web server, the browser can simply load them from the cache, which is stored on your local hard drive. Remember that the browser can read data from the browser cache much faster than it can read the files from the web page. So we just understand one thing from web cache, and that is making a faster loading in websites while browsing the internet. Up next, we have another software cache named disk cache. Most HDDs and SSDs include a small amount of RAM that serves as a disk cache. A typical disk cache for a 1 TB hard drive is 32 megabytes, while a 2 TB hard drive may have a 64 megabyte cache. This small amount of RAM can make a big difference in the drive's performance. For example, when you open a folder with a large number of files, the references to the files may be automatically saved in the disk cache. The next time you open the folder, the list of files may load instantly instead of taking several seconds to appear. Disk caching works under the same principle as memory caching, but instead of using high-speed SRAM, a disk cache uses conventional main memory. Disk caching can dramatically improve the performance of applications because accessing a byte of data in RAM can be thousands of times faster than accessing a byte on a hard disk. Next, we have the CPU cache, which is a hardware cache. A CPU cache is a hardware cache used by the central processing unit of a computer to reduce the average cost, time, or energy to access data from the main memory. Processor caches are even smaller than disk caches. This is because a processor cache contains tiny blocks of data, such as frequently used instructions that can be accessed quickly by the CPU. Modern processors often contain an L1 cache that is right next to the processor and an L2 cache that is slightly further away. The L1 cache is the smallest, around 64 kilobytes, while the L2 cache might be around 2 megabytes in size. Some high-end processors even include an L3 cache, which is larger than the L2 cache. When a processor accesses data from higher level caches, it may also move the data to the lower level cache for a faster access next time. In the end, we have the RAM cache. A memory cache, sometimes called a cache store or RAM cache, is a portion of memory made of high-speed static RAM, which is called SRAM, instead of the slower and cheaper dynamic RAM, which is called DRAM, is used for main memory. For example, if you are working on a video project, the video editor might load specific video clips and audio tracks from the hard drive into the RAM. Memory caching is effective because most programs access the same data or instructions over and over. Since RAM can be accessed much more quickly than a hard drive, this reduces lag when importing and editing files by keeping as much of this information as possible in SRAM. Cache memory is either included on the CPU or embedded in a chip on the system board. In newer machines, the only way to increase cache memory is to upgrade the system board and CPU to a newer generation. In the end, remember that the most caching is done in the background, so you won't even notice it is happening. In fact, the only one of the above caches that you can control is the browser cache. You can open your browser preferences to view the cache settings and alter the size of your browser cache, or empty the cache if needed. Thank you so much for watching and stay tuned for my next videos. Wishing you a wonderful time. Peace.